Today's lesson is 8.2, Exponential Equations. Let's go ahead and review some of our vocabulary. The common logarithm is the logarithm of base 10. Remember that we do see it written as so, and we all understand that there is the base 10 here, we just don't write it. A logarithm is, of course, the inverse operation to an exponential, and the natural logarithm is the logarithm with base e. Sometimes you see it written as so, but most of the times you see it written this way. The logarithm is the inverse operation to exponentials. That means that the logarithm of a number is the exponent to which another fixed number, the base, is raised to produce that number. Here are some examples. What we're going to see in this example is that the base in the exponential form is the same as the log. So take a look at here, and you can look all the way down the base 10 and notice that there's a pattern. We saw this in the last lesson when we changed from one form to the other, when we changed from this form to this form, when we changed from that form to that form. Okay, and so just to show you that it does work no matter what the base. What we're going to use today is called the power rule. When I have the log of a number that happens to have a power to it, so like 10 to the third power, I can rewrite it as the power times the log. This is going to help me to solve for the variable x. So notice in example 1, they want me to solve 6 to the x power equals 49. Now we could do like we tried last time, going over to our Desmos calculator and just start putting in numbers. But we're quickly going to see that it just doesn't work. Because 49 is a whole number, the exponent for x would have to be a whole number. It could not be a negative because 49 is not a fraction. 6 squared is 36, but once I put 6 to the third power in, I'm going to notice that I have much, much more than 49. And so what we're going to do is we're going to take the log or the natural log of both sides, and we're going to go ahead and that's going to help us find the value of x. We are going to go ahead and round our answer to the nearest 3 decimal places. So here we go. I'm going to go ahead and raise both sides to the natural log for this one. There's no reason that I'm choosing the natural log. It is clearly your choice. Both the log and the natural log will work. What I can see here is that this follows this same pattern. And so I can take my power and I can move it to the front in front of my log or my natural log. Both of them work. And so I can take and rewrite this one as x times the natural log of 6 equals the natural log of 49. Since I have my x all alone, right, which is what I want to do, all I have to do is solve. Because I want to get rid of that multiplication, I'm simply going to divide. I am going to divide by the natural log of 6 because that will cancel this out. Now what I'm going to do next is I'm just going to go into my Desmos Scientific Calculator. There it is. Perfect. And I'm going to go ahead and I'm going to put natural log of 49 divided by natural log of 6. Now you could use the A divided by B button that's right underneath the wrench. Remember, in the functions button is where you will find the natural log. And then you just start entering. You do not need to close the parentheses. As you can tell, it didn't make any difference when I did. But there we go. There's our answer. 172,066, and then there's a bunch more numbers. They wanted 3 decimal places, so I'm going to find the decimal 1, 2, 3. This number is going to tell me if I should round the 2 or let it rest, if I should add one more or let it rest. I'm going to go ahead and let it rest. There's my answer. Okay, and what you'll find is that if you use the log, you get the same answer. And since we have Desmos right here, we can quickly see that if we use the log of 49 and we divide that by the log of 6, notice we end up with the exact same decimal. So it doesn't matter. It's totally up to you. It's just really your preference. Okay, let me go ahead and clear all of that and let's try another one. So notice here in example 2, I do have a power to a power, or I have a base to a power, but notice that this is hanging around after it. So the first thing that I need to do is I need to get this base to the power, this exponential part, I have to get it alone. So I'm going to go ahead and the first thing I'm going to do is I'm going to add the 4 to the other side. I'm just simply following my rules of solving equations. Now that I have my exponent, my power by itself, now I can go ahead and I can take the log or the natural log of both sides. So last time, since we went ahead and did the natural log, I'm going to go ahead and do the log this time. So I'm going to take the log of 8 to the 2x minus 3 power, and I'm going to set it equal to the log of 9. Okay, I'm now going to apply the power rule because remember my whole goal is to get this variable x alone. So I'm going to apply my power rule by moving my 2x minus 3 to the front times my log of 8 equals log of 9. Okay, I'm going to do exactly the same thing I did last time. I'm going to go ahead and divide both sides by the log of 8. Now here's where we end up getting a little bit tricky because notice our x is not quite alone. Notice our x is not quite alone. I'm going to leave this as log 9 over log 8. Now, my intention is that that is going to go into the calculator, of course. This right here is going to go over here into my calculator, but I don't want to do it yet because I do not want to round in an intermittent step like this. If I were to do so, I end up with the possibility of rounding and wrong at the end, okay? So it's always best to round at the very, very end. And so something like this that, yes, it does need to go into the calculator, it doesn't need to go in yet. All right, so now I'm just going to go back and I'm going to follow my rules of solving my equation. So I'm going to add 3. And of course, because I cannot add the 3, I think I have some space up here. I cannot add my 3 to my problem, to my logs. I'm just going to add it on after. There we go. Now I'm going to go ahead and I've got to get rid of that 2. And it's being multiplied by my x, that purple one. And so I'm going to go ahead and divide by 2. Now, what I want to show you here is that's what you're thinking in your head, right? I'm going to divide everybody by 2. Now remember, when you go to put this in the calculator, you are going to put in there, it's going to turn out as log 9 over 2 log 8 plus 3 over 2. Okay, so that 2 is going to just go down with whatever's in the denominator of your log to begin with. So let me grab my laser here. This 2 is going to end up in the denominator here, and then it's going to end up in the denominator of this one as well. And that's always the rule when you have to do a division like this. Now I can grab all of this and let's go over to Desmos here and let's put it in. So I'm going to start with my fraction and I'm going to go grab my log, 9. I'm going to put 2. You can press times if you want, but you should be able to just go ahead and do log. And then I'm going to add my fraction of 3 halves. And there we go. There's my decimal right there. I would get the same answer if I had used the natural log. I'm not going to show you guys, but if you're not quite sure if I'm correct, go ahead and give it a try. And we'll go ahead and round to the nearest three decimals like we did last time. So 1, 2, and let's decide with our 8. There's a 3 after it, so it is going to rest. There we go. All right, let's give it one more try, just so that we can see all the different possibilities that Alex can give to you. So let me go ahead and clear my Desmos. Notice on this one that before I can begin, this is my base and here is my power. So I have to get rid of the 2. The 2 is being multiplied by my exponential function. So the first thing I'm going to do is divide both sides by 2. This is going to give me 7 to the 3x plus 1 power is equal to 24. Now I can go ahead and take either the log or the natural log of both sides. I'm going to go ahead and do the natural log this time, simply because I did the log last time. That's my only reason, really. No other reason than that. It is just personal choice. As you saw with that first one, either one will give you the correct answer. Now, just to help remind myself that I do need to get x by itself, I'm going to go ahead and make it purple. I'm now going to go ahead and apply my power rule, which says I'm going to take my exponent and bring it down to the front, times it by my natural log of 7 is equal to my natural log of 24. I'm going to go ahead and divide both sides by the natural log of 7. And I end up with, x is not quite by itself. 3x plus 1 is equal to the natural log of 24 divided by the natural log of 7. All right, just like in the last one, my x is not alone, so I'm going to have to go ahead and move the 1 by subtraction and then divide by 3. So I'm going to subtract the 1. I end up with 3x equals the natural log of 24 divided by the natural log of 7 minus 1. To get the x alone, I'm going to go ahead and divide by 3. Remember, when I do this, when I divide by 3 like this, the 3 is going to go into the denominator. Oops, there we go. I was thinking ahead of myself. In front of the natural log of 7, and then underneath the 1. Now that this is ready, this is now ready and can go into my calculator. Please, please, please don't put it in the calculator earlier. Don't go ahead and put this in the calculator. You don't want to head over to the calculator yet because it's going to mess up your answer when we're rounding. Okay, so let's go ahead and put that in. Natural log 24. Oops, hold on. 24, there we go. Get down in the bottom, natural log. Now, you don't have to worry about, am I using the right one? Just really whatever you choose to use in the numerator, log or natural log, make sure you use the same in the denominator. If I choose to use natural log in the numerator and I choose to use log in the denominator, it's probably not going to work. Yeah. All right, here we go. And if we round to the nearest 3 decimal places, 2, 1, and the third number is a 1, I want to check after that, the fourth number, it's a 0, so I'm going to leave it a 1. There we go. All right, the last 2 questions that you're going to see in your assignment today are going to look like this. Notice they're very similar to the last one. The only difference is I have an X on both sides. Take a look. There's an X here and there's an X there. The same process is going to be used to solve. I'm going to go ahead and take the log or the natural log of both sides. So since the last one I used the natural log, I'm going to go ahead and use the log for this one. And once again, The only reason I'm choosing the log this time is because I used the natural log last time. Okay, so it's really just your preference. If you like to use the log every time, the logarithm, go ahead. Uh, but if you like the natural log better, go ahead and use the natural log. So there we go. I'm going to apply that power rule by bringing my exponent to the front of my log. Now I'm going to try something a little bit different on this side. What I want you guys to notice is that there is an X on both sides. So what we would have done in the last one, problems is we would have divided both sides by the log of 11. But since there is an X on both sides, what I want to do is I want to take this side here on the left where my exponent had a plus or a minus between the X. Notice on the other side there's a times between the number and my X. This side has a minus, and sometimes you might see it as a plus. What you're going to want to do is distribute the log. Okay, you're going to want to distribute the log. So that's what I'm going to do. I'm going to say negative x times the log of 11 minus 10 times the log of 11 is equal to negative 2x times the log of 16. I'm just going to come back in and I'm going to make sure that I know where my x's are. Because the next thing I want to do is I want to get my x's on the same side. I want the x's on the side together. I'm going to move them to the left-hand side of my equals. And I'm going to take whatever doesn't have an x and move it to the other side, to the right-hand side. So this x can stay, but this x needs to come over here. Remember, whenever you are moving over your equal sign, you're going to be adding this. So this is just simply going to become plus log of 16, and I'm going to cancel it out, and I'm going to add it over here. Okay? Likewise, since this one does not have a log, I want to move it to this side. So basically, these two are going to swap places. And when they do that, remember, we're doing the opposite sign. So they're going to go ahead and they're going to add to go over to the other side. So basically, when these two switch, they switch and their sign switches. It's not just a simple, they switch places. The sign in front of them has to switch as well. So my next step is going to look like negative x times the log of 11 plus 2x times the log of 16. Let me get rid of that. Oh, that didn't look so great. There we go. And then the 10 is going to come over here, 10 times the log of 11. Remember, because it switched sides, it switched its side. All right, now my x's are together. And so the next thing I'm going to do is I'm going to factor out the x. So I'm going to put x, and I'm going to put a parentheses, and then I'm going to show what's left when I take that x away. Well, from the first one, I get negative log 11 plus 2 log 16. And then I'm doing nothing to this side over here. Okay? Now what I can do is I can think of this as x times this that I factored out. And now I can do my dividing and I can get x by itself completely. So I'm going to divide by negative 11 plus 2 log 16, negative log 11, negative log 11 plus 2 log 16. This is going to completely cancel out, leaving me my x. And now I can go ahead and this right here is going to go into my calculator. So let me go ahead and clear this. Here we go. Just be careful. A piece of paper is going to help you a bunch. I've already messed up, you guys. Oh my gosh, I should have put the 10 first. There we go. Log 11. There we go. And on the bottom, I'm just going to use the subtraction key to be my negative, and I'm just going to put it in. It will work perfectly fine. You are going to want to make sure that you do put in the parentheses in the bottom because you are doing that addition. There we go. There it is. There's my decimal. Uh, oops, I still have my laser. 7.618939, blah, blah, blah. Alex is going to ask you to round to different places. It might ask you for the 3 decimal places, the thousandths. It might ask you for the hundredths. Well, actually, let me scroll back up. This one actually came from Alex, so I can actually look. It does say to the nearest thousandth. Remember, that is like this, and you always put the decimal after the 1. So this is the 3 decimal places that we've been talking about. So we're going to go ahead and we're going to grab that guy. We're going to find our decimal. We're going to count 1, 2, 3. There's the number. This one's going to tell me if I should add one more or let it rest. Remember, 5 or more, we add one more. So we're going to go ahead and say 7.619.